Welcome to the A-335 VHDL Latches lab demonstration. This will be the long version. Okay, their first assignment in this lab is to create this Sr latch. This is an active low Sr latch with NAND gates, and when we push our key 0 or key 1, we're going to put a low in, and it should activate our Sr latch. We have a program, Sr Latch 1, but we also have our Sr Latch 1.qpf, which is our project file. And if we start with that one, it should preload most of the items that we're going to need for this lab. Okay, this program is going to be based on the logic diagram. So let's go ahead and get started. Here we are at our Quartus. And let's go ahead, instead of creating a new project, we're going to open existing project. So if we go back to our folder, which should be maybe on our desktop, go to VHDL Latches, open it up, and let's go to Sr Latch 1. And if we go to Sr Latch 1.qpf, that should be our project file. So let's go ahead and see if we can get everything we need when we do that. And our file's good. And let's just go and see if we've got our pin planner. And I'll be doggone, we do. So we have everything we need in order to run this program. Okay, so let's go ahead and compile it and program it, and we'll take a look at what it needs. And we successfully compiled it. So let's get rid of our compilation report, and we're going to go to program. Okay, here we're testing our Sr latch, and if I push the set button, we get a red LED which is set. I can do it multiple times and it doesn't change. And I push the key 1, which will be our reset. We get the green LED. And I can press it multiple times. If I press both, we're going to have a problem. We're going to get. Okay, the next project we have on our lab is to convert our existing program to another Sr latch, this one being with NOR gates. This is going to be an active high gates, and we're going to switch our push buttons with our slide switches. So we need to go in there and modify this. Again, this is a logic diagram program. Okay, let's modify this program. And to save time and aggravation, I'm not going to change the name of the program. So what happens over here is we are going to, Q is now going to be a reset. And our ands are going to be an OR, and our one on the bottom is going to be a set, and it's going to be an OR. And it looks like we have it. So we have our R and Q, and Q not coming up, and here we have our set and Q coming in, so that's good. So let's go ahead and compile it. Good, so let's go in and change our pin planner since we're using our switches. So our input into reset, let's go back, reset would be L22, and we could use our map here. L22 is going to be reset, and output, good. And our set is going to be L21, so let's go here to L, and that is going to be set, and it is going to be input tri-stated. So let's see here. So Q and Q naught should be, let's see, do they have a dual mode? No. Oh, bidirectional. Here we go. Okay. Let's compile it again and see what happens. Get rid of our compilation. And then once it gets done, we're going to go ahead and program it. Program, SOF, USB blaster. Perfect. Let's go ahead and try it. Our next assignment is we're going to build an SR latch, another one, and it's going to be based on behaviors, which is a programming language that will simulate this gate without utilizing the logic. We're back at Quartus, and I gave you the project, so let's go ahead and open existing project, and we're going to go back to our files, desktop, VHDL Latches, and we're going to try SR flip-flop, and we're going to use the project file, and it should preload everything for us. And it did. So let's go ahead and take a look at our pin planner, and it looks good. Okay, so let's go ahead and compile and run this, and let's try it. Okay, let's close out of our report, and let's go to program, and let's program our, we have everything. We have a SOF file, we got a USB blaster, so let's start. And we're successful, so let's take a look at it. Okay, before you run it, let's take a look at this program here. Here we've selected our ports, SR and clock, and Q and Q naught as our output. So this is a behavior. So it's a if-then statement, just like C and other programs. So if S equals 1 and R equals 0, then, okay, so Q equals 1. So if S is 1, R is 0, so if set is 1, reset is 0, we're going to get a set out. If not, so we're going to use an else if, set equals 0 and reset equals 1, then it's going to be 0. So if R is 1, it's going to be a reset. We're going to get a 0 on Q. Okay, and Q equals Q. This is if both of these are false, meaning no change, and our Q and Q naught are always going to be opposite. Okay, here's our SR latch. So this would be our reset. It's reset, so let's set it, reset, and you notice that I could push in set or reset multiple times, and I could do the same, and there is 0, 0, which would be no change, and we did not program the invalid condition, so we don't have to worry about that. Okay, so let's modify our last program to make a gated SR latch. Since a gated SR latch is active high, then we just need to add another copy and paste, and our clock is our input, so we're going to make that clock, and we're going to make that a 1 since it has to be a 1 to be enabled, And we're going to add it to the next one. Good. So, and everything else should be the same. So okay, we're going to compile it, and I need to make a modification to our clock and see if it pre-populates it. It won't give us a number, but it will add it to our list. So let's see here. Good. Close out. Let's go to our pin programmer, and clock did add, and we're going to go to M22. Oops. M22. We're going to go directly to our down list. Good. And we need definitely to have this one as a input tri-state because it's also a clock, and we don't want to write over that. So that's good. So I'm going to compile it and program it. Okay, let's try it out. Since this is a gated SR latch, we're going to need to open up our clock or gate. So here would be set, reset, and again I could do it multiple times, so let's go back to reset. And if we lose our gate, nothing will change. Perfect.